calculate the zeta when it turns 0 or the critical line, and I'm like, I can do 1 million terms, I can calculate the 1 million terms, and then it turns out that I actually need 1,000,000,000,000 terms for the output, for the zeta score, the output to cross 1. And then it was also erroring. So if you increase the interval, and so n to the power of s, especially if n is already like close to 1 million, and then you have to power it to s, and then s is like even like 68, so like 1 million to the power of 68, and then that starts to error. So that's 1 divided by n to the power of s. That should actually start to turn the value into negative. So at first, when the s is around 14, you will see it to be greater than 1. But then when you start increasing the interval and also with the n, it will error. So for just the summation part, it turns the denominator later on into negative. That's why it changes to 0, to closer to 0. But just regular summation is actually not something that is that you can really do for Riemann hypothesis. I think it says that you need to have more complicated stuff. I mean, I tried so many things like UDFs, but I just couldn't cross 1. Like I said, you need like 1,000,000,000,000, and then also the exponents get bigger and bigger, the divisor. So it's like it is very complicated. And so this one that I'm presenting, it's an approximation tool. So like it was designed in order to just give like a rough estimate of which interval to input, because you actually have if you input like the first zeta 0 is 14, and then you actually have to like increment it. It's actually to like really get close to the critical line, you have to increment it by 0.000. So it's given that really small increment, to get yourself closer to that, you have to know like when to actually begin, like which whole number to begin. So it's supposed to like tell you when it oscillates, when the output increases, from 0 to 1, then you're like at 7. Okay, start looking at that number 7. So and there could be more approximation tools. So it's like telling you that, okay, start looking in that number interval 7, that imaginary part. But actually the first one was in number 14, so interval 14. And it doesn't feel like it's a good approximation tool though. But doing the actual calculation, it involves 1,000,000,000 terms, and like I said, just 1 million is kind of difficult, if n is 1 million, because you have to like sum everything, and 1 is to s, then like 1 is to s, and 2 to the power of s, 3 to the power plus, and all that. Like I said, it already errors, not even close to 1 million. It errors. And also like by 68, by 58 interval, it also errors because the number is so large. So there has to be like a better tool, and I don't know yet. There were some that ChatGPT suggested, but it also errors, so kind of really hard to calculate. Because we're talking a divisor that you have to sum sequentially. One is to, and in fact, even a trillion is not enough. That's what ChatGPT said. So like you have to do 1 to the power of s, 2 to the, and go on. It's in sequential order, and it has to be at least a trillion for you to like really get close to that critical line. So